Okay, so can everybody hear me also over there from without the microphone, or shall I use the micro?
Very well.
Either, okay, yep. I thought nobody here heard the question, so nobody answered that, but apparently, yes. So the title of today's presentation, it's Internet of Things, what it is and what it should become. So I'll start with a short history of the Internet of Things because I think most people don't actually know how old the Internet of Things is and what it was originally. Now, okay, this screen is a little bit small, so I guess you might not be able to read it there, but I'll go quickly through this. So Internet of Things, the name was apparently coined back in 1999 by Kevin Ashton from MIT, and he well, the definition that he gave to the Internet of Things was really focused around RFID tags, so RFID tagging everything in the world, and how you can use that in supply chain management. So that was the original sort of intention or meaning of Internet of Things given back in 1999. Unfortunately, I still haven't been able to find any slides from that event or any article or whatever, but that was sort of the background of Internet of Things. So we jumped on this Internet of Things idea around 2000, and we wrote this, I wrote this middleware called Dialog. We had a team working on the Internet of Things back then, and we implemented different kinds of systems using RFID tags, barcodes, and so on for tracking shipments. Okay, this beamer, oh sorry. For tracking shipments with RFID tags, so we had these kind of systems for Finnish companies who built power plants in Chile, for instance. So what we did was that we put RFID tags on the different parts being shipped from different places in Finland, and then we could follow where they went by this what we call the ID at URI concept. So we just put into the tags the address of where we had sort of the agent or the information system that was interested in getting location updates for these parts, so that this company could follow what parts were moving where and being transported by whom and so on. But quite rapidly we saw that, location is just one attribute of shipments, but we might as well use the same concept for sending information about if a container fell into the water from the ship, or we could start sending sensor data, or we could start sending events about maintenance procedures and so on and so on. So this vision of the Internet of Things, I keep on saying that it's very similar to what the Internet of Things is nowadays. But and we actually presumably have the first scientific article in the world mentioning Internet of Things, published back in 2002. That's cited there. But something that's a little bit, I think, interesting about the scientific world in general is that we didn't actually manage to publish too well in the Internet of Things forums back at that time, because then Internet of Things was about RFID and supply chain management. So when we were writing about these sort of smart, intelligent products, sensors, and so on, we saw that now we're not very popular, so we actually switched to writing about intelligent products in around 2004. And it's sort of funny, okay, who could guess that the Internet of Things would eventually, 5 years later or so, become the big thing. So, but it wasn't so back then. And as we all know by now, I guess there's been a lot of, since the Internet of Things became a really big thing, there have been a lot of different people trying to invent new names for it. So we have cyber physical systems since about 2008, industrial internet, that's about applying Internet of Things to industrial systems more or less. And then Cisco has been very active in inventing new concepts, so we have Internet of Everything, Web of Things, that's W3C, Web of All Things, and so on and so on. But so everybody wants to establish his or her new label, but it's more or less everything more or less about the same thing. So to emphasize this, that what the Internet of Things was back in 2002, so I actually dug out an older slide that I presented at the TechS seminar on the 5th of May in 2002. The text here in black is what I had in that slide, that every physical object should possess a virtual counterpart or agent during its whole life cycle. That also includes human beings, so we should have some kind of agent managing our information, our data. And there were some people, okay, it wasn't a very big international event, but there was, for instance, Showman Datta, who's one of the guys at MIT who is now working on the industrial internet. Anyways, if you have a look at what the EU has written about what the Internet of Things is, it's really about this kind of concepts of virtual counterparts and so on and so on. So we still have the same challenges and objectives as back in 2002. There is a new initiative here in Finland that's called My Data. I guess there might be somebody here who's involved with that conference also. So that's again taking this kind of philosophy onwards and using this concept of that we would actually have all products and humans represented by some kind of a virtual counterpart or agent, so that we would be able to manage our own data. Okay, so that was the background. This is to say that even though we are not very aware of it here in Aalto or in Finland, but this kind of things, we have really been doing this among the first in the world. And it's funny enough that back in 2002, I think it was easier to actually implement this kind of Internet of Things system than it is nowadays. So maybe then a little bit onwards. So actually our view of what the Internet of Things should be has evolved since 2002. We had a big EU project called the Promise from 2004 to 2008, which was about managing the life cycles of different kinds of products. So we had companies such as Caterpillar, Iveco, Indesit, who make fridges and other household appliances, Intercom, who make telecom equipment, and so on. And the challenge of all these companies was to be able to collect information about the usage of their products, usage and maintenance of their products, so that they could use this information for doing better condition-based maintenance, but also so that they could improve both the design and the manufacturing of those products, as well as eventually when these products get to their end of life to check what parts can you reuse and so on. So our current definition of the Internet of Things and what it should be, or one of them, it's that it should fulfill the functionality that we have in this box here. Again, you won't see anything over there, I guess, but the Internet of Things should really be an information system architecture that allows me to find all the information that is all the information about my car, for instance, or about myself, or about that table there, no matter where that information is located. So some of that information will be, for instance, in my car's engine control unit, but there is also loads of information from its design, from the manufacturing, but also different maintenance operations. So if I take my car to this maintenance shop this year and to another one the next year, I would like the Internet of Things to enable fetching all that maintenance information and other information about the life cycle of the product. So what I have here, it's the building case. Well, that's maybe you saw in the first slide. So I'm officially professor in building information modeling or management. So we are working a lot with buildings and their life cycles. And there, of course, the challenges are even greater, because buildings have really long life cycles, and they tend to be rebuilt, modified, new building automation systems are installed, removed, and so on. So it's really a big challenge to actually keep the information models up to date with the real thing. So, okay, as I said, well, I'm being bold today or whatever, but since the world did follow our vision of Internet of Things back in 2002, so let's see if the world will eventually follow this definition too. Then to the things that we are doing just now. This is also a view of the Internet of Things, and it's related to an EU project that started in January this year. So it's called a Biotope. Biotope comes from building an IoT open innovation ecosystem for connected smart objects. And in this project, we are not dealing that much with the product life cycles, but we are dealing with smart cities, smart mobility, smart buildings, and smart equipment within buildings. Here in this slide, it just illustrates some of the use cases that we got from the partner cities in this project. So we have Helsinki, Lyon, and Brussels as the city partners. As the mobility partner, we have BMW, who's developing systems to connect the cars with the smart cities. And then here in Finland, we have Ensto Enervent and control things for smart building and smart equipment. So to illustrate what we are doing here in this smart city domain, I have this example of something that we will enable, hopefully, in this project, or that should be enabled. So we have this car, a BMW. I know it's not a BMW. I didn't find a photo that I could put in there safely. It's a Google Street car, and I have a Saab, but let's assume that it's a BMW that arrives to Helsinki, and this is indeed a Helsinki that we have here. So what will the BMW do when it arrives into Helsinki in the future once we have realized all these capabilities in Biotope? Well, first, it should be able to publish its own presence. So now I arrived into Helsinki, and it should be able also to find the information systems in Helsinki that are relevant for it and that it trusts to a certain degree. So that means that once it has found those other systems, it can start publishing information such as its own location, and the street temperature where it's driving, but that's not that interesting. What is more interesting is if it, Helsinki in the wintertime, it sometimes happens that it's slippery in the streets, so if the car's own existing this traction control system sees that now it's slippery, then it would send an event to the city infrastructure saying that in this specific location it's now slippery. Or what happens more and more often here in Finland is that you drive into holes in the street, so same thing, you could send events about that. And then eventually, once the systems in Helsinki have received this kind of information from 5 or 10 or 100 cars or whatever, then it can deduce that, well, you should maybe start telling all these BMWs and the other ones 50 meters ahead that it's slippery, so that they start avoiding these problems. So this is sort of a scenario where you can, or a case where you share information in exchange for services that improve your security. Then we also have this kind of cases. This comes from Brussels. So if you have a school class that ends their day, for instance, in 5 minutes, and I'm supposed to drive by that street. Apparently in Brussels they more or less block off the street for half an hour when this happens, so then we would like to have the kind of services which are in this case context-based. So the context is that I'm driving in this street, I want to go to this place, but there is something happening on the road, so I should be advised to change my route, in fact. Then, of course, we have the classical use cases also of finding parking places close to where I have a meeting, for instance, and reserving them. In this project, we actually have the BMW electrical cars, so then you would also like to check that there is a charging post, charging station available, there, and that it's able to charge my car enough so that I can actually get back home after my meeting. Okay, so this is the kind of systems that we will be implementing in reality. We might not implement this exact use case. We have several other ones, but I think this illustrates what the Internet of Things should be able to provide also in the future. So this slide sort of jumps in as not a surprise, but I still need to have it in this place. So in order to make this kind of systems work together, we of course have to have some kind of standardized protocols, standardized vocabularies and so on, so that the car can find the other systems and then eventually start communicating with them and sending these kind of events that I just mentioned. So what we did back in this Promise EU project, I already mentioned that we had many different companies from many different domains, and we had to get this information from all these kinds of products somehow collected in a uniform way. So there we specified what we then called the Promise messaging interface that enabled the doing of all this, and we took those specifications to the Open Group in 2010. The Open Group is a standardization organization, and eventually the modified specifications were published in 2014 under the name Open Messaging Interface and Open Data Format. So this is what I'll be showing as one way of actually implementing this kind of systems. So I'll be using some live demos. You will be seeing some XML and other technical stuff. I hope that will be okay for everybody. Okay, so let's go on. And I'm also actually the chairman of this Internet of Things work group at the Open Group. So we are really the architects behind these standards. That could be important and useful to know. So then this is maybe not a new concept, but I threw in this slide this year. So IoT could create, read, update and delete. People who are working with databases or something like this know about this IT concept. So remember this use case with the BMW arriving to Helsinki. So what happens first is that we have a new system that appears. So then that system needs to say, now I'm here, and it needs to find the other systems around it. So it needs to publish its presence somehow and say what are the services it can provide and what are the services it needs. Once these different systems have found each other, they can start communicating. So the car can start querying for different kinds of information, events and so on, and of course update that somehow. Then eventually the BMW will go away from Helsinki, so it needs to be removed from the system or parts of it. So the way in which we do this with OMI and ODF, so Open Messaging Interface and Open Data Format, it's that we, things they publish their available information using an OMI write operation. Then we have an OMI read operation by which you can ask for immediate values, historical values, so you can subscribe to different events and different data. And then we have an OMI write by which you can update information. So if you actually drive into a hole, then you would send an OMI write. Then with the students, I quite often ask, we didn't specify an OMI delete yet, and does anybody want to try to guess why we never specified an OMI delete? Actually, in one lecture, there was a student who guessed that straight away, but that's the only time.
With that right, you can remove, right?
No. Okay, in principle there is but then you rewrite everything.
Yeah.
But no, that's not it's a good try though.
Regret? You would regret it?
No, well, actually, it's because when we have this kind of systems with things that come and go, typically, especially when we were doing this RFID-based tracking, once you have lost the network connectivity, there's no risk that the product would send a delete event anymore to tell that I left, because it doesn't even have a connection potentially. So that's the kind of considerations which are sort of interesting when you get into this Internet of Things scenarios. Okay, then to the real stuff or the moving parts, meaning the live demos. So I've been using these for quite many years. This morning there's one of the systems that didn't work a moment ago, or I didn't get a connection, but let's try to deal with it anyways. So I'm now jumping over from the Helsinki and the BMW to the smart building and smart equipment case. So what you see here, it's actually a picture of our house in Porvoo, 60 kilometers some direction. So I'll be showing some of the systems from this place. So first, how you can get the current electricity consumption, but also how you can connect that to this kind of smart equipment, so an Enervent air handling unit or ventilation machine if you prefer. So now there will be some switching, and the whole point with showing these systems is to emphasize the need of standards and show how we actually use OMI and ODF for doing this kind of things. So to start off, this is a system that we wrote many years ago. It's been up and running for tens of houses in Porvoo for since about 2010, I would say. So it's a universal IoT platform, if you would like to call it this way. So what I'm doing now is that I'm getting a connection to this platform, IoT platform called Asemo, that we wrote a long time ago. And what I can see here, it's the total electricity consumption of our house with, in principle, 6 seconds precision. So and it should be updated about every 30 seconds. So if you noticed, those who were looking, this just moved a little bit forward. So I can actually see directly in real time with about 6 second precision what's happening there. We have had loads of other sensor inputs too. You can in principle connect any kind of measurements to this system. So we've had water consumption and many other things, and it's quite nice to to see what it looks like. But to be honest, everybody who has used this system, they tend to look at these graphs for the 1 or 2 first weeks to try to eliminate or get this base load here as low as possible, because that's the main thing that affects how much you actually pay for the electricity. But then afterwards, most people, they don't actually want to look at these graphs. They just want the inside air quality and climate to be good. They want to be sure that the building, that the house is in a good health in general, that it doesn't get mold or other things. And then after that, of course, if they can pay less for their energy on water and so on, that's interesting. How long did I say I was going to use? Okay, on 25 minutes. So this is one kind of Internet of Things platform, a generic one. I think we have developed something like 5 of them over the years since 2002, and in the world you have hundreds of them. There are big companies who even have several of them. I think Ericsson has maybe 3 or whatever. Then another platform, so this is to show what is the current state of the art of, so to say, smart equipment. So this is user interface that allows me to connect to this air handling unit, so the ventilation machine in our house that that takes care of exchanging the air and recovering as much energy as it can on the way. This is actually a software developed by Control Things, and it's been commercially available for 2.5 years. This is not to make a commercial, but it's good to know that this kind of functionality has been around for quite a while. So what happens with these new Internet of Things enabled devices is that when you switch on the power on this machine for the first time, if it's plugged into the internet, the machine itself tells me this its own serial number and gives me a PIN code so that I can connect to the machine in a secure way. So this has been saying could not connect to device. Okay, this is more or less the first time that this happens during a live demo. But I'm okay. This kind of things do also have some advantages in the sense that they show that it's really a live demo. Then the other thing is that this was extremely reliable as long as I had an ADSL connection to our house. But now I switched to a 4G connection. I won't mention which operator. A few months ago. And I didn't know that that connection actually goes down, I don't know how many times per day. Normally not for very long, but long enough to cut this connection. Okay, this machine does reconnect automatically, but my software it's 2.5 years old, so I should just update it. That's why we have this this problem here. So this time, exceptionally, I will have to connect to Enarvent's demo machine, so which is much less fun. But this is what, well, the kind of user interfaces that you can have. So I can actually control the machine directly here in real time. But what is more interesting is maybe that we have all these different, okay, our curves are much more fun at home. You have loads of sensors integrated in this machine already by itself. So you can measure humidity values, temperature values, and so on. And the thing that I'm usually demoing is the CO2 sensor that we have in our bedroom because we use that for limiting the CO2 level to 1000 ppm. And you can actually see from that curve, not this one because this is not our bedroom this time, sorry. You can see quite well when we went to bed, when we got up, how many people were sleeping there, and I always do this when we are traveling somewhere, of course, checking when I'm work traveling. Okay, one quick anecdote. It's we were on holidays in France 2 years ago, or well, 1.5 years ago, whatever, and our son was at home, and then I was checking these curves just to see if it was working or not, and then I saw that wait a minute, the CO2 level is high in our bedroom, but nothing in our boys' bedroom. So then we called him and asked him, why are you sleeping in our bedroom? So then apparently it was because the neighbors had a big party and they were making too much noise. So, well, I have a few of these anecdotes also about how I saw when the extraction fan had broken. But the point here is really that when you start developing any kind of IoT equipment or system, do think about security and strong security all the way. I think most building automation systems that are connected to the internet now, they have hardly any security because they just sort of connect existing closed low-level protocols directly to the internet, and there's typically no security. So if anybody switches off the lights, no, maybe not in this building, but yeah. But the point also with showing these demos, it's not just to show these systems, it's also to emphasize the fact that we here actually have two generic IoT platforms, even developed by us, but neither one of these actually publishes this information in a standardized format. So if I would like to use the same sensor, for instance the CO2 sensor of the air handling unit for some other system, or temperature sensors for several different systems, well, I can't do it easily. So then we will get to the XML stuff, OMI and ODF. And if you remember this, okay, still BMW arriving to Helsinki. Now what we have here, it's some small text, but I won't make it bigger for the guys in the back. I'll try to explain. So what we have here, it is a reference implementation of these two standards, OMI and ODF, that are running as a sandbox server here at Aalto. And what we are doing with this sandbox server is that we have different systems publishing their information here so that we can access that information and use it in different ways. So now if I click on this button, read all, then this will really be too small for most people. It's very good with these flat screens, but to be honest, sometimes beamers are still better due to the size of the text or contents. So this message here, it's the minimal, more or less the minimal OMI and ODF message that you can have. So I'm sending an OMI read command. Can anybody see this? Can you see this? Yep. Okay. And with an ODF payload that is just one line, and it says objects. So what I'm doing here is that I'm asking to receive all the objects and information that I have the right to see on this OMI node. So that's how this hierarchy here got populated. So I'm actually publishing the same information here from their handling unit as what you saw just a moment ago. And so this is okay. Again, I'm creating this kind of message, so I have an OMI read with a payload specifying that I want to know the current room removed air and supply air temperatures. So when I send these, sorry, this is much better to do online, and anybody of you can actually access it from this address. So then I will get the current value, so it's 21.1 degrees and 20.1 degrees. Now that's not that exciting maybe as such, but what is useful is that this information is published here using these two standards, so that means that anybody can start using this information and develop their own user interface. So we now have this user interface for this kind of machines, but once you have this data in this format, anybody could start developing other kinds of user interfaces and also combining information coming from different kinds of machines. So we have here also, for instance, connected a few hundred sensors in the K1 building over there, mechanical engineering. I haven't connected all the stuff that I have in our house, but here are some sensors, for instance, that I installed into a basement room wall. I won't spend too much on this because most of you don't see it anyways, but I'm monitoring the humidity and temperature values in 4 different points in the wall, so that I can have some kind of automatic agent detecting if there's too much humidity, meaning something coming in through the basement wall as humidity. Then, I didn't show all the functionality. Obviously, you can also subscribe to these values, update them, and so on if you have the right to do it. Now, this is just one example of the kind of user interfaces that we have developed for accessing the data on that sandbox server. So you all probably recognize that this is the map of Otaniemi. So we have 2 buildings, so actually one that's equipped with sensors. So this is showing one of the floors of this mechanical engineering building, and the colors correspond to the temperature map of all the rooms in principle in real time. What I can do is that I can go in, for instance, and have a look at one of the rooms more in detail. What was happening?
I sit in that that building.
Oh, okay. Which room?
Can you check if anybody's there? 229B.
Yeah, let's see. Yeah. I'll skip it this time. But yeah, we actually do have some real sensors here installed. We haven't installed them. It's a VTT and Samsung, or I don't know, some Korean guys. But what you can do here, for instance, in this system is that it knows, okay, I'm in this room, there is a sensor here, and I have an OMI ODF sensor that's unallocated for this room, so I can just link together the sensor. So there is a presence or light sensor also, yeah. So once I've done this, then I sort of link together the sensor with the visual model. What is important to understand from this is that once you have this kind of information published using this kind of standards, then you can connect it together different measurements with different actuators also, and create new rules. So, for instance, what would be a good case? Well, but you can do this kind of system integration without any programming. So, I have to come up with some example. I've had some, yeah.
What about someone with asthma who needs to have someone who needs a good temperature-controlled environment?
Yeah. Yeah, so you could sort of connect a new, better controller to existing sensors and made by somebody else than did the initial one. But a very simple example is that, well, if I put in a new button here for switching on or off the lights, then I could sort of just connect the signal of that button to the light controller. Okay. I think most people got the point, and I think I'm going even much more over time than I usually do. I don't usually go over time. Well, I catch up somehow at the end. So this is just a slide about the reference implementation. So we plan to disseminate this through iot.eclipse.org and promote, of course, these standards in many different ways. I won't go through the details here. It's okay. Yeah, I won't go through the details. Some words about security still. In this reference implementation, we are using something called access control list. So you can actually specify what users have read or write access to all the different levels in this hierarchy that you saw. So in this case, for instance, my air handling unit and my house, the equipment that I have in my house that sends this information has a certificate which is my certificate, and that's the only one that's allowed to update any information here. Now this is something that's still not very clear how to do it in a generic way in the Internet of Things, but you can actually do it quite easily once you have this information published using this ODF. So our vision, it's well, in this call, what the EU said in this ICT 30 call, where we got the funding from Biotope, it's that a real problem is the vertical silos of different systems. So all these different IoT platforms that all use their own sensors, their own APIs, their own protocols, and so on. So what we really want to do with this is to enable bidirectional control, not just sensors to cloud, but also control from the cloud back here, if and when needed. Communication between different clouds, from devices to other clouds, but also directly devices to devices, even if they wouldn't be in the same physical location, such as, okay, the BMW and Helsinki. Okay, they are in the same physical location in a way, but just connected by internet. So the conclusions, this is to be a little bit bold again. OMI and ODF is the same for IoT as HTTP and HTML for the web. Now I met some of the W3C guys, especially Dave Raggett. I don't know if you, but he was apparently involved in the specification of HTTP and HTML, and I asked him how obvious was it that the web would be created and everybody would start using HTTP and HTML, because it wasn't obvious at all that this would make a breakthrough. It could very well have gone so that, well, you had 10 or 15 different standards proposals, and instead of having one web nowadays, well, we could have 15 or 20 or I don't know what. And Well, I think it's quite easy for everybody to imagine what it would look like what the world would look like in that case, and what it would mean to the business. Most of the world business nowadays probably runs somehow through the web or is connected to the web, so it wouldn't be the same case. Then I have a line here saying IoT, it's about systems of systems. I think the IoT has become very sensor-centric, but we already have loads of these different platforms and systems for smart parking, smart vehicles, and so on. So what we really need to do now is to not to install loads of new sensors and actuators all over the world. It's to actually start using what we already have and make these smart systems communicate with each other. So the point here is, well, I think this is difficult. I'm not a very good PowerPoint person, so I was pretty happy when for once, had done an animation. So I'm still using this slide here. But in reality, what this is saying is that if we end up with an Internet of Things without standards, or as it is now, loads of different APIs, then well, there won't be much business in either, or it will be much more difficult to create that business. So then to the questions, and sorry for getting enthusiastic again, but I guess that's sometimes good also.
Questions?
Very preemptive, obviously. A preemptive presentation, obviously, because there are no questions.
I have one question, so not that important. Have you also worked with the lightweight M2M, MQTT, the other protocols that are working, that are quite in the forefront in the IoT world?
Yes, we have looked into them. There are many of them, as you said. Yep, that's one of the challenges. Before I start with them, we should remember we started with this back a long time ago, even before XML even existed. So, or before JSON existed. Yeah, well, you never know what will be the standards that break through. But coming to MQTT, that's a binary format. It's we have been using it, yeah. But let's say, you didn't say MQTT. You said
lightweight machine to machine.
Yeah, I haven't used that one.
Okay.
But yeah.
So that also seems to aim to solve similar problems of interoperability between systems.
Well, I can't say about that directly, but if I take the MQTT case to begin with, well, MQTT that's very good for collecting loads of data from sensors, for instance, in houses. Or in other cases, but MQTT, for instance, doesn't define any payload format.
Exactly,
So if we have actually used MQTT with one of the big IoT platforms, the way that they implemented MQTT for the Internet of Things was that in order to make it internet connected through the firewalls, they actually ran it on WebSockets. And the payload was an extremely badly formatted XML. So that means that with MQTT, the principle is that you should have very thin publish-subscribe layer, but then okay, it doesn't provide any sort of semantic layer for the payload.
So I mean, they're not contradictory, are they? As in, you could use OMI and ODF within MQTT.
Yes, you could, yeah. I wouldn't use MQTT and OMI, I would use either one, but I would definitely use ODF as a payload. One important thing there are many dimensions for analyzing and comparing these different protocols, but everything that we are doing and the OMI and ODF, they are really thought to be sort of peer-to-peer, to enable peer-to-peer based systems, which the typical publish-subscribe doesn't. It does usually assume that you have a third-party server collecting all the information, and that's why we are actually using the observer design pattern rather than publish subscribe. I think Co-op is using the same one, for instance.
Yeah, lightweight M12 is, for example, on top of co-op.
Yep.
Yeah,
Okay.
it uses
One more thing also, most of these protocols are mainly machine to machine, or have been that initially. There I would like to bring back into mind this picture of the lifecycle management. It's not just about sensors and low-level controllers. It's really about being able also to ask the Helsinki smart parking operator to reserve a parking place, which you can also do with these standards. I think you were.
Yeah. What is your kind of forecast for this interoperability issue? Like you are now part of one initiative, but there are probably many other initiatives as well. What are the key elements that determine which of these initiatives will be winning? Because it's not only the technical, the superiority that is, determines the success. It might also be the manufacturers who have a lot of role there. And so, what kind of are you in the right ship?
Yeah, we don't know. I think we are sort of in one of the smallest ships because I don't know why my colleagues went to the Open Group. They actually did go to IETF, maybe into W3C. I think we would have had much more success by now in that case. But anyways, yeah, okay. I agree. Standards don't usually win just by technical superiority. They win by getting adopted by a sufficient number of different actors. Now, with this Biotope project, the EU really pushes us to collaborate with the 6 other big projects developing this kind of systems. So we are, of course, pushing these standards, and we will be using them because we know how to actually implement these use cases easily using these standards. But of course, we are trying to convince the other ones also that they would make their lives easier if they would do the same. But well, it's not so obvious. But to be honest. For the moment, I think our project is the only one that actually has a clear solution of how to implement this kind of systems. Then we have Siemens and the big IoT project. They are very much involved with W3C, so the Web of Things initiative. I think that complements very well OMI and ODF, because I didn't show all the details, but ODF just specifies sort of this much of the semantic structure, object structure, but then you have all the definitions for how do you call an air handling unit, how do you say that the house is a house, how do you say that the temperature measurement is temperature measurement, and so on. So we are trying to work together with these guys as much as we can. So I hope we will converge.
Okay, thanks.
Yep.
Yeah, thank you. It was a very insightful presentation. I had a question related to the one vision which you envisioned about Amazon's cloud communicating with the Google Cloud with the Microsoft Azure. So do you foresee, how are these companies progressing? I suppose they don't want this to happen, or will they like this to happen, or?
That's a good point. I don't know about them, but for the moment, if I take to equipment manufacturer and car manufacturers and so on, and teleoperators, Elisa and Sonra and ThingWorks platforms and so on, they don't actually, for the moment, I'm not sure that they will are enthusiastic about opening up anything.
Mm-hmm.
They still try to dominate the others and gain competitive advantage by their closed systems, but I'm quite convinced that direction won't work in the end. Simply because all these cities that we have, the 3 ones in our project, but also all others, they are saying that no, we will not buy these solutions from ThingWorks or HP or similar, because if they do, it's very expensive. They're not very agile, and then they might be married with those solution providers for the next 50 years or so.
Right. And one more question about why did you select smart building? I mean, construction industry is like the slowest moving industry. So in terms of IoT, are the other industries? I mean, how are the other industries performing compared to the construction industry?
Construction industry is really slow what
Mhm.
comes to construction, but this life cycle management of buildings and building automation is quite a bit quicker.
Right. Okay.
And of course, personally I did that because I extended our house from 1954 a few years ago, so I installed loads of stuff there. And then our company Control Things is developing commercial software for companies in this domain. So, yeah. But yeah, we have played around a lot with cars, and we had for 1.5 years we had loads of vehicles at the Helsinki airport that fed into our platform, so we could see where they were and if they were being used, and also the Itella trucks and loads of fun stuff.
Okay, if there are no more questions, again, thank you, Kary Fraemling.